Ever wondered what the nearest planet to Earth is? If you're thinking it's Mars, you're not alone. Many might guess that, given how much we hear about the red planet. But it's actually Venus that holds the title of our closest celestial neighbor. Not only is it the brightest natural object in our night sky after the moon, but it's also the planet that comes closest to Earth, making it an object of fascination and intense study. Venus, named after the Roman goddess of love and beauty, is a world of extremes. It's the second planet from the Sun, and it's often referred to as Earth's sister planet due to their similar size, mass, and density, but the similarities pretty much end there. Now let's talk about distance. How close is Venus to Earth? Well, in the vast expanse of space, close is a relative term. The average distance between Earth and Venus is about 25 million miles. To put that into perspective, if you were to travel to Venus at the speed of a commercial jet, it would take you over 50 years to get there. But the distance between Earth and Venus changes as both planets orbit the Sun. At its closest approach, called inferior conjunction, Venus can come as close as 23.6 million miles to Earth. That's still quite far, but in astronomical terms, it's just a stone's throw away. It's also worth noting that despite being our nearest neighbor, Venus is not the planet we know best. Its dense, toxic atmosphere and scorching surface temperatures have made it a challenging place to explore. Yet the mysteries of Venus continue to captivate scientists and space enthusiasts alike. So next time you look up at the night sky and see a bright, shining object, remember, that's Venus, our closest planetary neighbor, a world of wonders waiting to be discovered. Now that you know Venus is the closest planet to Earth, let's explore it further. What makes Venus unique? Let's dive into the physical characteristics of our celestial neighbor Venus to find out. Just slightly smaller than Earth, Venus is the third smallest planet in our solar system. It has a diameter of roughly 12,040 kilometers, making it about 95% the size of Earth. Its mass is approximately 80% that of Earth, which means it's a pretty hefty celestial body. Venus's surface is a hotbed of activity, quite literally. The planet is known for its volcanic landscape, with countless volcanoes dotting its surface. These aren't your typical Earth volcanoes, though. The volcanoes on Venus are shield volcanoes, similar to those found in Hawaii. They're broad and low with gently sloping sides. Venus's volcanic activity is a testament to the planet's internal heat, which is a result of its size and composition. And if you think Earth's Grand Canyon is impressive, wait until you hear about Venus's rift valleys. These geological formations are the result of the planet's crust stretching apart, and they can be up to 200 kilometers wide. Some of these valleys, like Diana Chasma, stretch for over 6,000 kilometers. That's longer than the Nile River. But Venus isn't just a hot volcanic world, it's also shrouded in a dense, toxic atmosphere. This atmosphere is composed mainly of carbon dioxide with thick clouds of sulfuric acid. Not exactly a place you'd want to take a deep breath in. This toxic blanket traps heat from the sun, leading to a runaway greenhouse effect. The surface temperatures on Venus are hot enough to melt lead, averaging around 467 degrees Celsius. And let's not forget about Venus's pressure. The atmospheric pressure on Venus's surface is 92 times greater than Earth's. That's equivalent to being about 900 meters under the ocean on Earth. If you were to step foot on Venus, you'd be crushed almost instantly. This intense pressure, combined with the planet's scorching surface temperatures, makes Venus the hottest planet in our solar system, even though it's not the closest to the Sun. This might seem strange at first, but it's all due to Venus's thick atmosphere and its ability to trap heat. Venus is also known for its lack of a magnetic field, unlike Earth. This absence of a protective magnetic field means that the solar wind from the Sun directly interacts with Venus's atmosphere. This interaction leads to the gradual loss of the planet's atmosphere over time. Despite its beauty in the night sky, Venus is a harsh world with a hostile environment. Yet it captivates our curiosity, beckoning us to learn more about its fiery surface and dense, toxic atmosphere. And who knows, maybe one day we'll uncover more of Venus's secrets, revealing a past that's as intriguing as its present. Well, what does the Venusian sky look like? Well, imagine a world shrouded in a thick, dense atmosphere composed primarily of carbon dioxide with clouds of sulfuric acid. This is the reality of Venus, our closest planetary neighbor. The atmosphere of Venus is an intriguing and extreme example of a planetary atmosphere vastly different from our own. Venus's atmosphere is around 96% carbon dioxide, a greenhouse gas that traps heat. This is complemented by a small proportion of nitrogen and trace amounts of other gases like sulfur dioxide. But it's the clouds that really set Venus apart. These aren't your everyday fluffy white clouds we're used to seeing on Earth. Venus's clouds are composed of sulfuric acid, giving the planet its distinctive yellowish appearance. These sulfuric acid clouds create a thick, opaque layer that completely obscures the planet's surface from outer space. It's like a perpetual veil, shrouding the mysteries of Venus beneath. But these clouds do more than just obscure, they reflect sunlight. The high reflectivity of Venus's clouds makes the planet the brightest object in the night sky after the moon. However, this reflective quality has a downside. It contributes to the extreme greenhouse effect on Venus. You see, the sunlight that does get through the clouds is absorbed by the planet's surface. But the heat from that absorbed sunlight can't escape back into space. The dense atmosphere and reflective clouds work together to trap the heat, causing temperatures to rise dramatically. In fact, Venus holds the title for the hottest planet in our solar system, even though it's not the closest to the Sun. The surface of Venus can reach a scorching temperature of over 860 degrees Fahrenheit. That's hotter than the surface of Mercury, which is closer to the Sun. So Venus's atmosphere is not just a blanket of gases, it's a pressure cooker, a furnace that sustains incredibly high temperatures. The thick atmosphere of Venus creates a pressure cooker effect, making it the hottest planet in our solar system. How does Venus move in space? This is a question that has intrigued astronomers for centuries, and the answer is just as fascinating. Venus, like all planets, has two primary motions: rotation and revolution. To put it simply, rotation is the spinning of a planet on its axis, while revolution is the orbit of a planet around the Sun. However, Venus's motion is somewhat unique compared to other planets in our solar system. Let's start with Venus's rotation. Most planets rotate in the same direction they revolve around the Sun, a motion known as prograde rotation. But Venus does the opposite. It rotates on its axis in the opposite direction to its orbit around the Sun, a motion known as retrograde rotation. Imagine if the Earth spun from east to west instead of west to east. That's what's happening on Venus. Now you might be wondering, why does Venus rotate this way? Well, scientists believe that a massive collision with another celestial body early in its history could have caused this unusual rotation. This collision would have imparted a significant amount of angular momentum, causing Venus to spin in the opposite direction. Next, let's discuss Venus's revolution. Venus takes about 225 Earth days to complete one revolution around the Sun. This is the shortest orbital period of any planet in our solar system, making Venus's year the shortest. However, Venus's rotation is incredibly slow. It takes about 243 Earth days for Venus to complete one full rotation on its axis. Yes, you heard it right. Venus's day is longer than its year. This slow rotation, combined with the planet's dense atmosphere, results in very long days and nights. In fact, a day on Venus, from one sunrise to the next, lasts about 117 Earth days. This unique combination of a slow rotation and a quick revolution means that from the perspective of someone standing on Venus's surface, the Sun would appear to rise in the west and set in the east, opposite to what we're used to here on Earth. As a result of its unusual rotation, Venus also experiences a phenomenon called retrograde motion. From our perspective on Earth, there are periods when Venus appears to move backwards in the sky. This is simply an optical illusion caused by the relative positions and motions of Earth and Venus, but it's a spectacular sight to behold. So how does Venus move in space? It spins backwards slowly and orbits the Sun quickly. This gives it a day that's longer than its year, sunrises in the west, and periods of retrograde motion. These unique characteristics make Venus one of the most intriguing planets in our solar system. Venus's unusual rotation gives it a day that's longer than its year. Isn't that something to ponder? What have we learned about Venus through space exploration? Well, quite a lot, actually. The exploration of Venus has been a fascinating journey, filled with numerous missions and discoveries that have significantly expanded our understanding of this enigmatic planet. Our voyage to Venus began way back in the 1960s with NASA's Mariner missions. Mariner 2 was the first successful mission to Venus, and it provided us with the initial data about the planet's temperature and atmospheric conditions. From this mission, we learned that Venus has a scorching surface temperature, hotter than a typical oven, and an atmosphere dominated by carbon dioxide. In the 70s and 80s, the Soviet Union's Venera program took the exploration of Venus to new heights. The Venera missions were the first to land a spacecraft on another planet and send back images. These missions revealed a landscape of flat plains, high mountain ranges, and vast volcanic structures, painting a picture of a world that was both alien and eerily familiar. Fast forward to the 21st century, and the exploration of Venus has become a truly international endeavor. The European Space Agency's Venus Express, Japan's Akatsuki, and NASA's Magellan have all made significant contributions. These missions have given us a wealth of information about Venus's geology, climate, and atmospheric dynamics. From Magellan's radar mapping, we discovered that Venus has more volcanoes than any other planet in the solar system. Venus Express helped us understand the complex dynamics of Venus's super-rotating atmosphere, and Akatsuki is currently studying Venus's climate and weather patterns. But perhaps the most exciting discovery of all came in 2020, when scientists detected phosphine gas in Venus's atmosphere. On Earth, phosphine is produced by microbes that live in oxygen-free environments. Could this be a sign of life on Venus? The jury is still out, but this discovery has certainly piqued the interest of scientists around the world. The exploration of Venus hasn't always been smooth sailing. The harsh conditions on Venus have led to many mission failures, and the intense heat and crushing pressure have made it impossible for any lander to survive on the surface for more than a few hours. However, these challenges have not deterred us. Instead, they have spurred us on to develop new technologies and innovative approaches to space exploration. As we continue to explore Venus, each mission brings us one step closer to unraveling the mysteries of our nearest planetary neighbor. We've come a long way since Mariner 2's first flyby, but there's still so much more to learn. Our exploration of Venus continues to uncover its secrets and increase our understanding of our nearest planetary neighbor. What role does Venus play beyond science? This is a question that takes us on a journey through time, culture, and mythology. Venus, our neighboring planet, has been more than just a celestial object across various cultures and mythologies. Its brilliance in the night sky has made it a symbol of many things, most commonly associated with love, beauty, and femininity. In Roman mythology, Venus was the goddess of love and beauty. She was born from the foam of the sea and was considered one of the most beautiful and charming deities. This association has carried over into modern times, with Venus symbolizing love and beauty in many aspects of culture. This is not unique to Roman mythology. In ancient Greece, Venus was known as Aphrodite, again a goddess of love and beauty. The planet was named Aphrodite's star, symbolizing the goddess's connection to the heavens. In Mayan culture, Venus had a dual role. It was both a symbol of the morning and evening, representing the duality of life. It was also associated with the god Kukulkan, a feathered serpent deity who was linked to the planet. In Hindu mythology, Venus is known as Shukra, a teacher of demons and the lord of love and indulgence. The planet is considered a positive celestial presence, symbolizing wealth and pleasure. Even in modern times, Venus continues to inspire. It's been the muse for artists, poets, and musicians, symbolizing love, beauty, and the feminine divine. From Botticelli's Birth of Venus to the famous tennis tournament Venus and Serena Williams, the influence of Venus in our culture is undeniable. So, what role does Venus play beyond science? It's a symbol, a muse, a celestial embodiment of love, beauty, and femininity. It's a testament to our collective imagination, a source of inspiration, and a bridge between our past and present. Venus's brilliance has captured the imagination of people throughout history, and it continues to do so, reminding us of our deep connection with the cosmos and our shared human experience. Could anything live on Venus? That's a question that has puzzled scientists for decades. When we picture life as we know it, Venus seems like the last place we'd expect to find it. And yet, there are tantalizing hints that life might exist, or could have existed, on this fiery planet. Let's start with the challenges. Venus is a veritable inferno, with surface temperatures hot enough to melt lead. Its atmosphere is thick and oppressive, composed mostly of carbon dioxide with clouds of sulfuric acid. And let's not forget the crushing pressure, over 90 times that of Earth at sea level. If there's life on Venus, it would have to be extraordinarily resilient to survive in such extreme conditions. But life on Earth has surprised us before. We've found organisms thriving in the harshest environments, deep sea vents, acidic lakes, even inside rocks. These extremophiles have expanded our understanding of where life can exist. Could similar life forms be eking out an existence on Venus? That brings us to the recent discoveries. In 2020, scientists announced they detected phosphine in the Venusian atmosphere. Here on Earth, phosphine is produced by bacteria in oxygen-free environments. Could this be a sign of life on Venus? It's a tantalizing possibility, but it comes with a heavy dose of skepticism. There are non-biological ways to produce phosphine, and the detection itself has been questioned. More research is needed to confirm these findings and explore their implications. Another intriguing clue comes from Venus itself. Some scientists propose that Venus was once a habitable world, with liquid water and a climate similar to Earth. If that's true, life could have originated during this benign period and then adapted as conditions became more extreme. We see this pattern on Earth where life has proven remarkably adaptable to changing environments. So, could there be life on Venus? The short answer is, we don't know. The longer answer is a little more complicated. While the current conditions on Venus seem inhospitable, the possibility of life, past or present, can't be ruled out. The discovery of potential biomarkers like phosphine opens up a whole new line of inquiry. It challenges us to think about life in new ways, to expand our definitions and our expectations. The quest to find life on Venus is far from over. It's a puzzle that's waiting to be solved, a mystery that's begging to be unraveled. With every new discovery, we get a little closer to answering that question. Could anything live on Venus? While the current conditions on Venus seem inhospitable, the question of life there remains open. The search for life, whether on Venus or elsewhere in the cosmos, is a testament to our curiosity, our resilience, and our unending quest to understand our place in the universe. What's next for Venus? As we gaze into the future, the exploration of Venus promises a fascinating array of possibilities. This celestial neighbor of ours, shrouded in mystery and thick clouds, is set to be the destination of several planned missions, each with its unique set of objectives and scientific inquiries. First on the horizon is the Envision mission. Slated for launch in the latter half of this decade, this European Space Agency-led endeavor seeks to understand why Venus and Earth, despite their similarities, took such divergent evolutionary paths. Its sophisticated instruments will probe the Venusian surface and atmosphere, hoping to unravel the planet's geological history and shed light on its volcanic activity. Beyond Envision, NASA is also making significant strides with two ambitious missions, Da Vinci Plus and Veritas. Da Vinci Plus aims to plunge through the Venusian atmosphere, examining its composition and how it interacts with the planet's surface and the solar winds. On the other hand, Veritas will map Venus's topography in high resolution, seeking clues about the planet's internal geodynamics. Coupled with these missions, the Indian Space Research Organization is also planning its first-ever Venus mission, Chandrayaan-1. The probe will focus on studying the planet's surface and its atmosphere, aiming to deepen our understanding of the chemical composition and dynamics of the Venusian atmosphere. Each of these missions is a testament to our collective curiosity and our quest to understand the cosmos. They will help us learn more about Venus's past, present, and possibly its future, paving the way for even more discoveries and potentially even manned missions in the far future. As we continue to explore Venus, who knows what new mysteries we'll uncover? The future is a canvas of infinite possibilities, and Venus, our enigmatic neighbor, is a testament to that. As we journey onwards, one thing is for certain: our exploration of Venus is far from over. It's just the beginning. So, what have we learned about our nearest neighbor, Venus? Well, let's take a step back and reflect on this celestial odyssey we've embarked on together. We started by introducing Venus, the planet that shines the brightest in our night sky and the closest one to Earth in our solar system. We delved into the physical characteristics of Venus, discussing its size and mass, which are similar to Earth. But that's where the similarities end. Venus is a scorching hot world with surface temperatures hot enough to melt lead. We then journeyed into the thick, oppressive atmosphere of Venus. Composed largely of carbon dioxide with clouds of sulfuric acid, this atmosphere creates a greenhouse effect that traps heat and makes Venus the hottest planet in our solar system. We also explored Venus's unique rotation and revolution. Unlike most planets, Venus rotates on its axis in the opposite direction, and it takes longer for Venus to rotate once on its axis than it does to orbit the Sun. Quite peculiar, isn't it? We then discussed humanity's exploration of Venus. From the initial flybys by Mariner 2 to the detailed studies by the Magellan spacecraft, we've learned a great deal about this enigmatic planet, yet much remains unknown. We also touched upon Venus's role in culture and mythology. Known as the morning and evening star, Venus has inspired awe and wonder in countless generations. We pondered the tantalizing question, could there be life on Venus? While the harsh conditions make it unlikely, some intriguing discoveries suggest the possibility of microbial life in the planet's upper atmosphere. Finally, we look to the future of Venus exploration. With several missions planned, there's much excitement about what we might discover next. Venus, our closest neighbor, is a fascinating world with many secrets yet to be discovered. And with every new mission, every new discovery, we step closer to unlocking these secrets. So here's to the future and to the endless possibilities it holds.